Okay, we're going to talk about two separate things. We're going to talk about changes and we're going to talk about properties. So we're going to talk about physical and chemical properties and physical and chemical changes. All right, so we're going to discuss what they are, examples of them, what they mean, all that good stuff. Again, here's the objectives. Pause it and peruse it if you wish. Okay, we're going to do properties first. Two types of properties, physical and chemical. What do I mean by physical properties of matter? They're properties that can be determined without changing the nature of the substance. So water would still be water. Sodium chloride would still be sodium chloride. Carbon dioxide would still be carbon dioxide. Examples of these kind of properties, the color, the state of matter, texture, melting point, boiling point, mass, volume, luster, a whole slew of things. We aren't changing the nature of the substance, we're just describing it in some way. Chemical properties, on the other hand, are properties that only can be identified by either going through or trying to cause a chemical change. So for example, does something react with oxygen? Does it react with water? So the reactivity with water or the reactivity with oxygen. Is it flammable? What's its half-life? What about corrosion? Okay. Here's an example, oxygen, some physical properties. Colorless, odorless, it's a gas. Chemical properties, supports combustion and it's soluble in water. Mercury, physical properties, it's a silver whitish color, it's a liquid metal. It combines with chemical properties, it combines with sulfur at room temperature, it reacts with nitric acid, and it oxidizes when heated in air. So those are the chemical properties. So physical properties, I don't change it, I just describe it. Chemical properties, I try to change it. All right, now you may have heard of extrinsic versus intrinsic properties. They're also called extensive and intensive. So extrinsic, extensive, same thing. Intrinsic, intensive, same thing. Confusing, I know, but they just call them different things. So what does intrinsic mean? Intrinsic means that property exists and it does not depend on the amount of the substance I have. That property is the same no matter what. So why? Because it exists within the substance. So intrinsic, intensive, within the substance. So for example, paper burns. Small pieces, big sheets, still burns. Other properties that are intrinsic, the density, the melting point, state of matter. Again, it doesn't depend on the amount of the substance. It's just a property of that particular substance. Extrinsic, on the other hand, depends on the amount of the substance that you have. And typically this refers to size measurements. So length, well, the length is going to be different. Do you have a big piece or a small piece? Mass is going to be different. Is it large or small? Okay, so intrinsic, it's just a property of that substance. Extrinsic, it's a property of that amount of a substance. So it depends on the amount. All right, now that we went over properties, now it's time to move on to changes. And just like properties had physical and chemical changes, same deal. All right, so energy, we kind of have to address it a little bit. Energy literally means the capacity to do work. So you could be moving an object, breaking a bond, generating light. And energy is always involved when matter changes. So physical changes. Physical changes only affect the physical properties. So remember all those physical properties? That's it. Ice melting, all changes of state are going to be physical changes. So when ice melts, the substance is still H2O, only the physical state changed. With chemical changes, like that candle burning, one or more substances change into entirely new substances with different properties. So hydrogen gas and oxygen gas can combine to form water with totally new properties. Chemical changes always occur when a new substance is produced. Again, I mentioned already, hydrogen gas and oxygen gas combine to form water. New substance, new property. There are some important signs of a chemical change to know. There are 4 main signs. You may see other places that list more signs, but we're going to focus on these 4. The more signs you observe, the more likely it is that it's a chemical change. Some physical changes can have one or more of these signs, so it's not a guarantee. First thing, production of a gas. So you see bubbles. That's a sign. There's a formation of a precipitate. So you take two clear liquids, you combine them, and it gets cloudy. You see a precipitate form. That's a solid. You get a release or an absorption of energy. So it gets hot, it gets cold, it gives off light, it gives off sound. Okay, a release or an absorption of energy. Or there's a color change, completely changes its color. All right, so is photosynthesis, in which light energy is captured by plants to make sugar from carbon dioxide and water, a physical change or a chemical change? So think about it for a moment, because you're going to have to explain, what is it? Well, it would be a chemical change, because the products which you end up with are different substances than what you started with. We got new substances with new properties. Every chemical change involves, which one? Belle has something to say. Yep, the formation of a different substance. Did you know that, Belle? Volume is which type of property? Extensive or intensive? Extensive. Okay, it depends on the amount of the substance you have. What are the signs of a chemical change? Remember, there are four main signs of a chemical change. Do you remember them? Right? Gas bubbles, a precipitate, giving off or absorbing energy, or a color change. Flammability is which kind of property? Chemical property. And in class, we'll be doing a Blue-Kit to review, super fun. And that's it. That covers physical changes, chemical changes, physical properties, chemical properties. And hopefully you learned something new today.